Hello, good afternoon, students. I hope you all are fine. So, in the last class, we have seen permeability, coefficient of permeability, seepage velocity, and all. So, now we will solve some problems on that. So, I'm sharing the screen. I hope it is visible to you. Okay. So, what it says, the discharge of water collected from a constant head perimeter in period of 15 minutes is 400 ml. So how much is the discharge of water collected from a constant head perimeter in a period of 15 minutes is 400 ml. The internal diameter of the perimeter is 6 centimeter and the measured in heads between the two gauging points 15 centimeter apart is 40 centimeter. Calculate the coefficient of permeability if dry weight of the 15 centimeter long sample is 7 Newton and specific gravity of the solids is 2.65. Calculate the seepage velocity. So how we are defining the discharge of water collected from constant head perimeter in period of 15 minutes is 400 ml. Discharge is given to you and time is given to you. How much? 15 minutes. The internal diameter of the permeameter is 6 centimeter. Internal diameter is 6 centimeter. And the measured in heads between the two gauging points is 15, two gauging points 50 centimeter apart is 40 centimeter. Measured in head between the two gauging points 15 centimeter apart is 40 centimeter. Calculate the coefficient of permeability. If dry weight of 15 centimeter long sample is 7 Newton and specific gravity of the solid is 2.65, calculate the seepage velocity. So capital Q is given to as 400 ml. Small t is 15 into 60. It is 15 minutes into 60 second, 900 second. Di equal to 6 centimeter, H equal to 40 centimeter, D is equal to 15 centimeter, K is you need to calculate. WD is 7 Newton, L is 15 centimeter, G is 2.65. Vs you need to calculate. So your K is equal to QL divided by ATH. Q is 400 into L is 15. A is pi by 4 into D square, that is 6 square, into T into TH is time is 900 into 40, H is 40. So it comes out to be 0.005893. R is 0.005893 centimeter per second. Now V is equal to Q divided by T into A. So Q is 400, T is 900, area is pi by 4 into D square. 5 by 4 into 6 square, it comes out to be 0.0157. So your V will be equal to 0.0157 centimeter per second. After the calculation of V, you need to calculate V naught. V naught is nothing but A into L. Area is pi by 4 into D square, 6 square into L is 15. So it comes out to be 4 to 4.17 centimeter cube. And here gamma D is equal to WD by V naught. WD is 7. V naught is 424.17. So this comes out to be 0.0165 Newton per centimeter cube. Or gamma D is equal to 16.5 kilonewton per meter cube. Gamma D equal to G gamma W by 1 plus E. Gamma D is 16.5. G is 2.65. Gamma W is 10. 1 plus E. So your E comes out to be 0.607. N is equal to E divided by 1 plus E, which is equal to E is 0.607, 1 plus E. 1 plus E is nothing but 0.607. So your N comes out to be 0.3777. So your Vs is equal to V by N. V is 0.0157 divided by 0.377. It comes out to be 0.0415 centimeter per second. So your Vs is equal to 0.0415 centimeter per second. So in a consolidation test, the Voigt's ratio of soil sample decreases from 1.0 to 1.10. In a consolidation test, the Voigt's ratio of soil sample decreases from 1.2 to 1.1 when the pressure is increased from 160 to 320 kilonewton per meter square. Calculate coefficient of consolidation if the coefficient of permeability is 8 into 10 raised to minus 7 mm per second. So your E1 is equal to zero point 0.2, E2 is equal to 1.1, E1 is equal to 160, P2 is equal to 320. MV is equal to AV by 1 plus E1. So AV is equal to delta E by delta P 1 plus E1. So delta E is nothing but 1.2 minus 1.10. That is E1 minus E2. Delta P is 320 minus 160. 1 plus E1 is how much? 1.2. Actually, E1 is 0.2. So 0.2 plus 1 will give you 1.2. So MV comes out to be 1.375 into 10 raised to minus 3 meters square per kilonewton. So your K is equal to CV MV gamma W. So your CV is equal to K divided by MV into gamma W, or CV is equal to 8 into 10 raised to minus 10. MV is 1.375 into 10 raised to minus 3 into 9.81. So your CV comes out to be 5.93 into 10 raised to minus 8 meters square per second. Therefore, MV is equal to 1.375 into 10 raised to minus 3 meters square per kilonewton, and CV is equal to 5.93 into 10 raised to minus 8 meters square per second. So what are curve fitting methods used in consolidation test? Explain any one. So the different curve setting methods used in consolidation test are square root of time fitting method, logarithm of time fitting method. So what is square root of time fitting method? This method consists of drawing the curve between the root of time under root as abscissa and dial reading R, representing the compression of the specimen as ordinate for any pressure intensity or for any pressure increment in the consolidation test. The initial dial reading R0 corresponds to the time t equal to 0 and b equal to 0. The straight portion is produced back to meet the ordinate at reading RC, which is called the corrected zero reading, and the consolidation between R0 and RC is for initial consolidation. From RC, draw another line B such that its abscissa at every point is 1.15 times that of line A. Intersection of the B with the consolidation gives a point P corresponding to 90% U, whose dial gauge reading and time may be designated as R90 and T90 respectively. From the curve, we get under root of T90 as 5.5 or T90 equal to 5.5 square. So the coefficient of consolidation can be calculated from the equation CV equal to TV90 D square divided by T90. So now we will understand what you mean by Moore Coulomb theory for shear strength of soil. Moore Coulomb failure theory. So this theory is based on the assumption that a relationship exists between shear strength and normal stress can be represented by a straight line. Moore's theory also states that the shear strength depends on the normal stress, but it emphasizes that it is not a linear relationship. So what Moore's theory states? This theory is based on the assumption that a relationship exists between shear strength, and normal stress, and can be represented by a straight line. Moore's theory also states that the shear strength depends on the normal stress, but it emphasizes that it is not a linear relationship. So if you see the figure, that is Coulomb envelope tau, and this is tau C, this is sigma. Morse envelope. However, from both Moore and Coulomb concept, it is concluded that Moore Coulomb envelope can be considered to be a straight line if the angle of internal friction phi is assumed to be constant. So depending upon the properties of the material, the failure envelope may be straight or curved and may pass through the origin of stress. So how do you classify the shear test based on drainage conditions? Drainage is not permitted at any stage of the test, hence no time is allowed for dissipation of one water pressure and consolidation also. No significant volume changes are expected. Usually 5 to 10 minutes may be adequate. Undrained tests are after performed only on soils of low permeability. So consolidated undrained test. Drainage is permitted during the application of normal stress and no drainage is permitted during the application of shear stress. Volume change do not take place during shear and excess pore water develops. After the soil is considered under the normal stress to the desired degree, 5 to 10 minutes may be adequate for the test. Drain test or slow test. Drain is permitted fully before and during the test. No excess pore water pressure develops at any stage and volume changes takes place. It may require 4 to 6 weeks to complete a single test on a cohesive test. So this completes our preparation with respect to exam. I hope it is clear to you. If not, you can just drop a message in the comment box. If not, you can call me at 8553171859, or even if you can mail me at nadim@keyben.university. So I'm stopping to share this screen. Now we will see one more interesting topic that is applied with respect to applied geotechnical engineering after a 2-minute break. So I'm sharing the screen. Hope it is visible to you. So first is define disturbed soil sample. So disturbed soil samples are the soil samples in which natural structure of the soil gets disturbed during sampling. So what is happening during disturbed soil sample? Disturbed soil samples are the soil sample in which natural structure of the soil gets disturbed during sampling. So what is it? Disturbed soil sample? Disturbed soil samples are the soil samples in which natural structure of the soil gets disturbed during sampling. Define area ratio. डिस्टर्ब सैंपल मतलब एक ऐसा सैंपल जिसमें नेचुरल स्ट्रक्चर सॉइल का डिस्टर्ब हो जाता है ड्यूरिंग सैंपलिंग. Next is area ratio. So how you will define area ratio? It is defined as ratio of maximum cross section area of cutting edge to the area of the soil sample into 100. So how you are defining area ratio? It is the ratio of maximum cross-section area of the cutting edge divided by area of soil sample into 100. It is AR is equal to D2 square minus D1 square divided by D1 square into 100. Next comes undisturbed soil sample. So which type of soil sample you call it undisturbed soil sample? Undisturbed soil samples are the samples in which the natural structure of the soil and the water content are retained during sampling. So during sampling, what will happen? Undisturbed soil samples remains same. They do not get affected. Undisturbed soil samples are the soil samples in which the natural structure of the soil and the water content are retained during sampling. So what is recovery ratio? Recovery ratio is nothing but ratio of length of sample recovered on sample tube to the total length of penetration of sample tube. So how we are defining recovery ratio? It is nothing but ratio of length of sample recovered on sample tube to the total length of penetration of sample tube into 100. In define inside clearance. So how we are defining inside clearance? D3 minus D1 divided by D1 into 100, where D1 and D3 are the diameters of sample tube 1 and 3. So define outside clearance. So how we are defining outside clearance? Outside clearance is equal to D2 minus D4 divided by D4 into 100, where D2 and D4 are the diameters of sample tube 2 and 4. So now we will see what do you mean by contact pressure. Define contact pressure. So contact pressure is defined as the vertical pressure at the surface of contact between the base of surface of footing and the underlaying of soil mass. So how we are defining contact pressure? Contact pressure is defined as vertical pressure at the surface of contact between the base of the surface of footing and the underlaying of soil mass. क्या है कॉन्टैक्ट प्रेशर? कॉन्टैक्ट प्रेशर का ऐसा वर्टिकल प्रेशर है सरफेस ऑफ कॉन्टैक्ट में बिटवीन द बेस ऑफ सरफेस ऑफ फुटिंग and the underlying of soil mass. So write an expression for computation of secondary settlement consolidation equation. So how we are defining consolidation settlements? SS, it is equal to C into H into log to the base 10 Ts minus Tp divided by Tp, where H is the thickness of layer, Ca is the secondary compression index, Ts and Tp are the time factor in seconds. Define stress isobar. Stress isobar is a curve or contour connecting all points below ground surface of equal vertical stress. So what is stress isobar? Stress isobar is a curve or contour connecting all points below ground surface of equal vertical stress. स्ट्रेस आइसोबार क्या है? एक ऐसा कर्व या कॉन्ट्रैक्ट कांटर है जो कि कनेक्ट कर रहा है पूरे पॉइंट्स को बिलो ग्राउंड सरफेस ऑफ इक्वल वर्टिकल स्ट्रेस. Write an expression of computation of consolidation settlement. So consolidation settlement is given by SP equal to U into SR, where U is the degree of consolidation which varies from 0 to 100%. SR is the total or final consolidation settlement. Consolidation settlement equation is SP equal to U into SR. Write an expression for computation of immediate settlement. The immediate settlement SI is given by SI equal to QB into 1 minus mu square into IF divided by ES. So Q is the intensity of contact pressure, B is the least lateral dimension of footing, mu is the Poisson's ratio, ES is the Young's modulus of elasticity of soil. IF is the influence factor which depends on L by B ratio. So state the different types of settlement of footing. So the different types of settlement of footings are foundation settlement, immediate or elastic settlement, primary consolidation settlement, secondary consolidation settlement. So four types of settlement are there. Number one is foundation settlement. Number two, immediate or elastic settlement. Number three, primary consolidation settlement. Number four, secondary consolidation settlement. Next is define finite and infinite slope. So how you will define finite slope? If slope is limited extent, if the slope is up to a limited extent, then it is called finite slope. Infinite slope. Any slope of great extent is considered infinite slope. So we will wait for there. So I'm sharing the screen. I hope it is visible to you. So define finite slope and infinite slope. So how you will define finite slope and infinite slope? If the slope is of limited extent, then it is called finite slope. अगर slope का जो extent है इसकी limit है, then it is called as finite slope. If any slope of rate extent is considered as an infinite slope. Define active pressure. The minimum lateral earth pressure is known as active pressure. So how you will define active pressure? कम से कम जो lateral earth pressure act करता है उसको हम बोलेंगे active pressure. Minimum lateral earth pressure is known as your active pressure. Define passive pressure. Maximum lateral earth pressure is known as your passive pressure. So active pressure and passive pressure are opposite to each other. Active pressure is minimum lateral earth pressure, whereas passive pressure is maximum lateral earth pressure. State the drawbacks of Rankine's theory of earth pressure. So the drawbacks of Rankine's theory are the back of wall. The back of wall is smooth, is far from truth. What is the drawback of Rankine's theory? The back of wall is smooth, is far from the truth. The resultant earth pressure always acts parallel to the surface of backfill. So what are the assumptions made on finite and infinite slope? The assumption made on finite and infinite slope are the failure of earth slope occurs along a slip surface. The assumptions made on finite slope and infinite, the failure of earth slope occurs along a slip surface. कहाँ पे होता failure of earth slope occurs along a slip surface. The sliding wedges moves a rigid body. क्या हो रहा? The failure of earth slope occurs along a slip surface. The sliding wedges moves a rigid body. So the assumptions made on finite and infinite slope are the failure of earth slope occurs along a slip surface and the sliding wedges moves a rigid body. Now coming to module 4, define gross bearing capacity and net pressure intensity. So how you will define gross bearing capacity Q? The total pressure at the footing due to weight of superstructure or self weight of the footing and weight of earth fill is called as gross bearing capacity of soil. So how you will define gross bearing capacity of soil? The total pressure at the footing due to weight of superstructure. कितना प्रेशर डेवलप होता है किसकी वजह से? ड्यू टू वेट ऑफ सुपरस्ट्रक्चर या फिर सेल्फ वेट ऑफ द फुटिंग एंड वेट ऑफ अर्थ फील, दैट वी कॉल्ड एज ग्रॉस बेरिंग कैपेसिटी ऑफ सॉइल. नेट प्रेशर इंटेंसिटी क्यू यू. So how you QN? Net pressure intensity is difference in intensity of the difference in intensity of gross pressure after construction of structure and original overburden pressure. QN is equal to Q minus sigma naught. How we are defining net pressure intensity? Qn, it is equal to Q minus sigma naught. The difference in intensity of gross pressure after construction of structure and original overburden pressure. Qn is equal to Q minus sigma naught. Differentiate between ultimate bearing capacity and net bearing capacity. The ultimate bearing capacity QF, the minimum gross pressure intensity at the base of foundation at which the soil falls in shear. That is net ultimate bearing capacity is equal to QNF equal to QF minus sigma naught. Next, define net safe bearing capacity and safe bearing capacity. So net safe bearing capacity QNS is equal to QNF by F, or F is the factor of safety. So how we are defining net safe bearing capacity and safe bearing capacity? Net safe bearing capacity QNS is equal to QNF by F, where F is the factor of safety. Safe bearing capacity QS is equal to QNS plus sigma naught, where QNS is QNF by F plus sigma naught. So list the different types of foundation. So the different types of foundation are shallow foundation, deep foundation. Difference between safe bearing capacity and allowable bearing pressure. Safe bearing capacity is the intensity of loading that will cause a permissible settlement or specified settlement for a structure. नाम ही मालूम पड़ रहा सेफ बेरिंग प्रेशर क्या है, ऐसी इंटेंसिटी ऑफ लोडिंग दैट विल कॉज ए परमिसिबल सेटलमेंट और स्पेसिफाइड सेटलमेंट फॉर ए स्ट्रक्चर. Allowable bearing pressure क्या है? Allowable pressure bearing pressure is the net intensity of loading at which neither the soil fails in shear nor there is a excessive settlement determined to the structure. Next is anchor piles. How you define anchor piles? Anchor piles are used to anchorage against horizontal pull from sheeting pile or other pulling forces. Whereas instead the use of compaction piles. So where compaction piles are used? Compaction piles are used to compact loose granular soil in order to increase the bearing capacity. So what are end bearing piles? End bearing piles are used to transfer load through the pile tip to a suitable bearing stratum passing soft soil or water. Lastly, list the uses of laterally loaded piles. The uses of laterally loaded piles are to support horizontal or inclined forces such as foundation of retaining wall, bridges, and dams. Write the equation for converse Lebesgue formula. Neta g equal to 1 minus theta by 90 m into n minus 1 plus n into m minus 1 divided by mn, where m is the number of rows, n is the number of piles in a row, theta is tan inverse of d by s in degrees, d is the diameter of piles, and s is the spacing of pile in the group. So this completes our 2 marks question. If you have any doubts, you can just place a message in the comment box. If you have any queries, you can contact me at nadim@k1.universities, or even you can call me at 8553 171859 during night hours. So I hope you have understood the concept. So this completes our 2 mark question, and so have a nice day.